Hi, Cora Stack here. This is Dr. Stack. I'm a mathematician by training, so I have had a huge interest in curriculum design for a long time because I'm very interested in education, mathematics education. But I fundamentally, I'm a mathematician, with an interest in mathematics education, and I would be on the uh, very much on the rigorous side, that it's important that we teach rigor. I wouldn't be on the side, say, of Professor Joe Bowler. I would have a different point of view to Professor Joe Bowler on many things, but great respect for her, but would differ hugely in terms. And I certainly on this issue, I would say I have a much better perspective, a better perspective here. But this is nothing personal. So, secondary mathematics in the age of artificial intelligence, what must change? That's Professor Joe Bowler of the University of Stanford. I haven't actually heard her talking about this, surprisingly. It wouldn't really fit in with her usual approaches, but perhaps we'll hear from her shortly. So, secondary mathematics in the age of artificial intelligence, what must change? Yes, the Irish Times asked me to rebut her many years ago, and in fairness, they were very good. They gave us space to rebut, and we did a very good job, in fairness. AI is not fundamentally a coding problem, it is a mathematical system. Secondary mathematics is no longer fully aligned with the world students are entering. So that's a statement. In the age of artificial intelligence, this is no longer a minor issue. It's a structural one, because artificial intelligence is not fundamentally a coding problem or a system. It is a mathematical system. But of course, they're both interdependent. But fundamentally, without mathematics, there would be no artificial intelligence. And yet, in many education systems, the mathematics that underpins artificial intelligence remains fragmented, as mathematical education systems, underdeveloped or introduced too late or not at all to form a coherent foundation, for example. In this video, I want to explain what is missing, why it matters, and what must change. At its core, because artificial intelligence is moving so fast that we really got to change our curriculums, and we've got to do it really fast. And it doesn't require rocket science. Was that something that was used in rocket science? That's something used Shania Twain's album. I'm using it this way. At its core, artificial intelligence rests on a small number of deeply connected mathematical ideas. Linear algebra, of course, that's a whole one of the most powerful areas in mathematics, and I think it's brilliant because it has the power in it and the simplicity of it and the structure. It's just incredible. Mathematics, absolutely beautiful. Optimization, multivariable calculus, probability. These are not specialized topics. They're the structures that allow systems to represent data, transform it, that's the vectors, the transformations are done by matrix transformations, learn from it, that's optimization. There's this constraint and optimization. There's two areas there. We study a little bit of constraints in sort of basic constraint strength problems are studied in the Irish project maths, or what's called the higher maths, but it's very basic, and make decisions under uncertainty. And we've removed vectors, which are the representation of it, and we've removed matrices, which are and most of optimization isn't there. So vectors represent information, matrices encode transformation, and there's no reason at all why any of this shouldn't be on a higher level leaving certificate. Gradients drive learning, and probability handles uncertainty. This is the mathematics of modern systems, and increasingly it's the mathematics of modern life. So I never thought I would be in this position where my favorite subject would be the foundation of artificial intelligence. So I'm still saying, wow, I was all right all the time. And I knew it should never have been removed from the leaving certificate. Absolutely knew it, but I didn't know this was coming around the corner, did I? So artificial intelligence is now embedded in healthcare, finance, education, public policy, and everyday digital life. But there is a fundamental question we're not asking clearly enough. Absolutely. Are we preparing students properly to understand these systems and in time? And not just to use them, but more importantly, to understand them. Because without that understanding, we risk creating a generation of users, but not thinkers. participants but not decision makers, and that has consequences, educational, societal and democratic. So the curriculum problem, one of the central problems lies in how mathematics is currently organised or presented and taught, and we have this concept of teaching areas in strands. Now, students study algebra, calculus, probability, vectors. Well, vectors have been removed from the Irish curriculum, but in most advanced curriculums, vectors are up to 3 dimensions are there, and matrices are there, for example, in further mathematics and in the international baccalaureate. Those kind of they're top dollar here, but still there's gaps there in terms of what could be put in here very easily into these to bring it up to speed with what's needed to understand artificial intelligence. But these topics are often taught separately. That's in strands. I disagree with this particularly in primary school, because it's a lot of these strands are very superficial. There's no depth in them, with limited emphasis on how they connect. The result is fragmentation. Mathematics becomes a system or a collection of techniques, often very superficial, rather than a coherent system of ideas. But in artificial intelligence and in modern STEM, these ideas do not work in isolation. They work together. Vectors represent data, calculus describes change, and optimisation drives improvement. Now that's a huge thing for artificial intelligence, but it's actually very basic mathematics. Very basic. Probability manages uncertainty. When these connections are not made explicit, students cannot see the structure, and it's like mystified. The whole thing is a mystery. It's not a mystery. It's pure and utter, very, very powerful, but understandable mathematics, provide it's properly taught and explained. And without structure, there is no real understanding. These issues do not exist in isolation. Over recent decades, organisations such as the OECD, this is an issue I have with when they do the PISA test, and I've had it for quite a while, but I would even see it more of an issue now. So the OECD have had a significant influence on curriculum development across many countries. Much of this influence is exercised, as we know, through international assessments such as PISA. PISA evaluates students at age 15. This has led to important and positive developments, but of course a lot of comparisons which may be unhealthy. There is now in PISA greater emphasis on problem solving, modelling, data literacy, so everyday life mathematics, you could say. But is this really what we need for artificial intelligence? If we need deep learning of deep structure? They are valuable advances, but also, unfortunately, at this stage raises a deeper structural question, because many of the mathematical ideas that underpin artificial intelligence, linear algebra in its full form, multivariable calculus, optimisation, and deeper probabilistic reasoning are typically developed later.